shape the modules. Right? You shape the modules, so it's a partial shading problem. So 50 modules, and you can see now, right? This is the peak. If there is no shading, the curve looks like a blue color. Now because of shading, the curve becomes a red color. Multiple peak. Right. So we test it. So we have a PV array simulator. So this simulator, right, you can make the pattern, the shape. So it is like your sun. This is a sun, but this sun can work at night. Anytime, raining, anytime. So you can make that curve. Remember that curve comes from the equation, right? The equation comes from the physical model. The physical model will show you the PN junction. So basically this is, right, emulating the sun. So we do all the experiments, right, to see how the result is. So we compare the PSO, this is soft computing method, and the PNO, the normal traditional method, conventional method. You can see that for PSO, so you can see, right, the output here, the power, right? So you put a shading here, right? So this is uniform. You put a shading here, right? So you can see that this is normal. Shading comes, right? And then it will track here at about 700 something. Okay? So for PNO, okay, there's coming here. Can you see the oscillation? Because PNO has oscillation. Right here, there's no oscillation. One advantage of PSO, no oscillation. And when the track comes, it cannot track. Right? So it's stuck at about 600 something like this. Okay? You lost some power. Here 700 something, you lost about 100 watts from there. Okay? So you can also have experimental can show the same result that we showed just now. Okay? Doing the experiment, okay, to show that the PSO track the fast shading there. Right, then we do efficiency test. So we test the system with the array. So we have 10 hours profile, right? This is your radiance. And you can see the efficiency is very high. 99.5 efficiency for 10 hours. Okay, if you run this with PSO. Now that's a hardware, software solution. We can also use software solution, hardware solution. So the most prominent is called microinverter. So microinverter, right? Basically, it's a small inverter. So every PV, every module has its own inverter. So this PV has own inverter, this is own inverter, everyone has own inverter. Remember our normal system is the PV is connected in series, right? And then you have one big inverter. Now you have all small, every PV, everyone have microinverter connected. So if this is shaded, right, will not affect this. Right? So it will not affect this. Only this has no power, but this will still give power. But for the previous one, you have one module shaded, the rest are affected. So this solution is called microinverter. So it has own MPPT inside here, higher efficiency but more complex in the wiring, and also we have to put this inverter underneath the module. So you open up to the sunlight and harsh condition environment, so it's going to be very tough for the inverter to stay there for a long time. But this one solution. So the other solution is called DMPPT, right? This one, you buy a chip, right, and connect every chip like this. So one PV, one chip, one PV, one chip. We call it DMPPT chip, and you connect them to the central inverter. So the configuration is the same like before, but you have every PV one chip extra. Okay. So this is a very nice solution. So we can buy this chip. It's a chip available in the market, SPB 1020. This is the DMPPT chip we call it. So you connect that to your PV in between the PV and the inverter. So the other one is called energy recovery circuit. So this one is more complicated. So basically you are storing, one this is shaded. So you bypass the PV one, for example, and you will store the energy for some time, and then after that you will recover and send back to the grid. So it is a very nice circuit. So we published this circuit in this transaction previous last 2 years. So that circuit will also increase efficiency. So it is the operation of the circuit. Right, I just finally show a comparative study on the techniques to increase the yield during fast sharing. So we have situation, this is the condition that we have, the modules, the inverter. So we shape them and see which technique gives the best. So we publish this in this journal. So we give some shading pattern, shading pattern like this. Sometimes it's full sun, sometimes quarter sun, sometimes half sun. So we give the shading pattern variation, and we run the simulation, and you can find that, this is the, in general, you can see that the for shading pattern, dia tak sama tau, shading pattern tak sama, jawapan dia, sebab it can be very, sometimes the pattern can be different, sometimes this is shaded, this is not shaded, this is shaded, so because you don't know how the shading going to be, so you have to try every option. So we find that the best result come from microinverter, efficiency is very high, and then energy recovery, and then the PSO, and finally the PSO. So it means that you invest more money for the hardware, you can get better output results. Right, in conclusion, the fast shading is a serious problem that can cause substantial power loss in energy yield. Conventional MPPT methods are unable to track the global correctly. New software methods seem to be more suitable, but hardware solutions give better efficiency, but with added costs. You pay extra to get extra power. Thank you for your attention. So I welcome any questions that you have, if you have. Okay, thank you very much. Yeah.
What kind of what kind of apparatus that you use to detect the efficiency of the MPPT? What or how do you use to detect the efficiency of MPPT? The first thing that you show that the MPPT cannot track the MPP.
Right. Thank you very much. I think the question is simple, but actually the concept is quite difficult. MPPT is not a hardware efficiency. Okay? It's not like you have a black box, You put wire here, in, wire out. You put a multimeter, measure voltage, measure current, get power input, measure output, power output. So efficiency is P out over P in. Itu kepahaman kita lah kalau kita cakap efficiency kan. Kita tak macam itu. MPPT is a software efficiency. I mean the algorithm efficiency. I show you.
Yes.
Actually, the algorithm efficiency means, usually you have to pick, Let's say the peak equal to 1. Okay? If your algorithm cannot push your operating point to that 1, for example, it goes to 0.95, tak sampai peak kan? That's efficiency 95%. Okay? You understand?
Yes,
So
understand.
to measure that, you need this called software. Dekat dalam algorithm tu. This measured here. Right? This is MPPT efficiency. So now efficiency is about berapa tu? 90 something kan? Dia naik turun kan?
Yes.
Itu efficiency. Dibandingnya here, efficiency very poor. Dia tak dapat track.
Yes.
So you can see efficiency is low. When it tracks, go very high. So this is the efficiency I'm talking about.
Yeah.
So once it track, 100%, it tracks sekejap. So you have to log, right? In millisecond, you have to log, and then you sum all of them, right? You run the inverter, so you log all this efficiency in millisecond, you store it, and then you count one by one, and get the total efficiency for the whole day or for 10 hours, for 10 hours, 10 days, whatever. Efficiency is now poor. You log this data. So basically the algorithm yang buat ni, yang merah tu algorithm ni yang tadi tu, PNO tu yang tak berjaya kan. Dan algorithm tu yang lemah lah. Dia tak berjaya pergi ke hijau. Sampai ke hijau dia akan turunkan efficiency tu, you log that. That's called MPPT efficiency. Yang kotak tu, power in DC, power out AC, tu bagikan power out dengan power in, itu dipanggil conversion efficiency. Okay? So total efficiency of the inverter is equal to conversion efficiency multiply MPPT efficiency. So yang conversion efficiency itu physical. You can measure with a meter. MPPT tak boleh measure dengan meter. Ada algorithm software ni untuk measure dalam apa berlaku algorithm tu. Macam mana dia gerak tu, you kena tengok dari dalam software. So you need a special tool to do that. Tak boleh buat dengan sebab tak ada. Tak boleh measure. Kita kena measure dengan tool ni. Ya, dalam ada sensor dia dalam dalam algorithm ada sensor. So good question. But of course you can do a simulation by MATLAB. Boleh, tak salah, itu tak ada masalah. You can do MATLAB simulation, you can do Simulink. Tapi real physical one you cannot measure in normal way. I can have a tool to do that. And the tool is very expensive. I show you the tool, right?
Yes.
That's a box. Solar array simulator. Okay? Ada soalan lagi? Our Encik Azlan is also doing some similar work. He's still pursuing the same area of MPPT. But it's a very important work. I told you, right? People try to increase the efficiency of the MPPT because it's the cheapest way to increase efficiency. It's just the software, right? It's just the codes, right? Changing the codes, PNO, the PSO, you change the codes only inside the algorithm. So that's the cheapest way to do things. But if you have higher efficiency, then you put hardware solution, micro inverter, energy recovery circuit, and sebagainya. Then the solution is more expensive but higher efficiency. Whether you have to do it or not, it's up to you, right? You pay more money, you get better efficiency. Memang ada big sikit lah, MPPT konsep agak big. So dia pun makan masa nak faham MPPT ni apa benda. Sebenarnya di algorithm, efficiency algorithm. Bukannya hardware, voltage, current measure dekat luar pakai meter, bukan. Bukan. Dia adalah how good your algorithm can track the maximum point. Kalau dia boleh lekat, maximum point tu lekat gitu kan, kalau dia tak melekat kan, 100%. Dia tukar pun ikut, tukar pun ikut, tukar dia ikut kan. Macam-macam magnet dia lekat. That's the best. Of course, when the radiant change dia akan drop, tak sempat nak ikut. Tak sempat nak ikut kan. It's too fast going down. So the algorithm slow, tak boleh ikut, then efficiency is lost. Okay. Boleh kan? Boleh lah, kita cuba faham. Saya fikir sebenarnya kita faham je. Susah nak faham. It will take time to understand. But it's a very active work. You can see publication in this, not publications. Recent publication, people are doing all sorts of crazy things that try to improve the MPPT efficiency. Okay? Ada soalan lagi? Right. So most of the inverters now you buy in the market, right? But the modern inverters, they have these partial shading algorithm embedded inside. This means that when you install inverter, partial shading, they know what to do. They will try to do the best tracking, find the global peak. The old inverters, right? 10 tahun dulu, dia tak tahu. So dia akan stuck dekat situ forever, and that's why you find dia punya efficiency very low. Remember, when the efficiency or PPT very low, then total efficiency is low. So the system dia dapat output sikit, sikit. Sebab remember, bila one module tu kena fast shading, the rest are all affected. Okay, one module kena, semua affected. Kecuali kalau you pakai microinverter, satu modul kena, lain tak affected. Tapi kalau pakai string, satu modul kena, semua affected. So that's one the issue yang besar lah dalam fast shading ni, because right, the modul kena shading tu bukan dia kena shading, dia memang kena shading, tapi kesan dia pada semua sistem akan go into trouble. So that's why the modern inverter, they have ability to do this fast shading, tracking, and also checking to make sure that even fast shading is there, so still they can get the maximum power by tracking the global peak. Okay, terima kasih banyak. Thank you very much for your attention. So I hope that might not bore you. So anyone is interested to do some research, again, I welcome to work with me as a student or as well as some collaborators. Thank you very much.